given some vertices of a triangle, it's not a bad shout to just sketch this out. It doesn't have to be perfect, but it'll give us a bit of a feel for what's going on. Okay, so if I say that's about 5, and then that, yeah, that can be 5 as well. So I've got -3, 1. That can be my A. And then 5, 0 here. And then 9, 7. Let's connect these up to make our triangle. Show that AB equals BC. So let's work out them separately. We can use Pythagoras' theorem for this. We just need to, you basically just subtract the x's, square them, and I wouldn't say necessarily learn this formula, but it can be useful as long as you understand where it comes from. So I'm just finding the difference in the x's. That will tell me the base of the triangle, squaring it, and find the difference of the y's, squaring it. It's a squared plus b squared equals c squared then. So the difference between -3 and 5 is sometimes easy to just read it straight off. It's going to be 8, and then from 1 to 0 is going to be 1. So I'm going to get root 65 for AB. Then for BC, I'm going from 5 to 9, so 4 squared, 0 to 7, 7 squared, 16 plus 49, which is again root 65. So therefore, AB equals BC. Good start. So what I've just shown is we've got an isosceles triangle. We're now asked to show that angle ABC is not a right angle. So this one here. There's numerous ways to do this. You could look at the gradients and show that AB, the gradient of AB is not perpendicular to BC. That's one approach. You could use the cosine rule to work out the angle and show that it's not 90. But the quickest way to do it in this case, especially because we already have two lengths, is just to show that Pythagoras' theorem does not hold. We have to work out what AC is. That's going to be 12 squared from -3 to 9. Then 1 to 7 is 6 squared. So 144 plus 36, or root 180. Then we can see that that is the longest side. But AB squared plus BC squared is going to be 130, which is not then equal to AC squared, which is 180. So Pythag doesn't hold. So ABC is not 90 degrees. That's all we need to show for that. Now find the coordinates of the midpoint of AC. So for this, we can add the x's and divide by 2. -3 plus 9 is 6, divide by 2 is 3. Same with the y's. 1 plus 7 is 8, divide by 2 is 4. So it's 3, 4 here. From my midpoint, maybe I'll call it M. Just learn that formula. It's basically the mean of the two numbers. That will necessarily give you the middle value. I'm not going to derive it in any more detail. I'm just going to accept it. Now determine the equation of the line of symmetry of the triangle, giving your answer in this form. Okay, so the line of symmetry is going to go from the midpoint through B. Necessarily, it's going to look exactly the same either side. So what I'm going to need to find is the gradient of, first of all, AC or AM. Let's go with AC. This is part D. So m of AC is going to be 7 y2 minus y1, so 7 minus 1, and then just make sure you do it consistently, so it's now 9 minus 3, which gives 6 over 12, or a half. And therefore, m of, m of m to b, because that's what we're interested in, is this is going to be a perpendicular line. I should have said that. This is necessarily going to be a right angle. So I've worked out the gradient AC. Now I want the gradient MB. It's just going to be the perpendicular. M for gradient here, M for the point, midpoint here. So minus 2. Y minus y1 equals mx minus x1. We showed that we had 3, 4 in the previous question. So y minus 4 is going to be minus 2x minus 3. That means that 2x plus y, and we're asked to write it so it's equal to a constant, so that is going to equal 10. Nice. Write down an equation of the circle with center A, which passes through B. Okay, so we've got the center is minus 3, 1, and we just need to, well, it's going to have radius AB, which we've worked out before. We've found that it was root 65. So I can just write it here, x plus 3 squared plus y minus 1 squared is going to be r squared. R is root 65, so this is going to be 65. Remember, if the center is AB, then it's x minus a squared plus y minus b squared equals r squared. Actually, that is an application of Pythagoras' theorem. I've just applied it here. The very last bit of this question says that the circle intersects the line of symmetry at B, as we can see, and at a second point. It's up here. Find the coordinates of the second point. Now look, it's only one mark. We do not have to set up simultaneous equations to solve this. We need to think about it carefully. There's a circle theorem that says if you draw a chord and then draw the perpendicular bisector, then it will necessarily go through the center. And the converse is also true. If you draw a line that goes from the center and is at right angles to a chord, which is what we do definitely have here, then it will be a perpendicular bisector. So this length is the same as this. And furthermore, we're going to basically create what's going to be a rhombus. We can extend the triangle and draw it like that. And there's going to be, we can just say, right, I'm at 5, 0. So to get from 5, 0 to M, which is at 3, 4, I'm actually going left 2, and I'm going up 4. So then I can just do it again. I can go left 2 and up 4 again, which is going to take me to 1, 8. That is necessarily going to be the point in question. We're just following the gradient really, because we're going up, we're going left. We do this in a different color. We're going left and up, and so we just go left and up again by exactly the same amount. We'll get to that other point where it hits the circle because of these circle theorem ideas. Just follow the gradient, which gives us 1/8.